What up, nerds? I'm Bryson. You can call me Bammed, and this is CTF and Cigars by Bam CTF, where I light up a cigar, talk about CTFs, hacking, security, and whatever else happens to come to mind. So last week, we went over a Try Hack Me room. It was a beginner level malware analysis, static malware analysis room on Try Hack Me. It was pretty good. Had some really easy samples to kind of go through and get the basics of static analysis. I thought we'd continue the trend this week and do some more static analysis. But this week we're going to look at a .NET sample. I'm not going to go through Try Hack Me. Just look at something that I collected in my day-to-day work. So anyway, but before we get into that, we're going to go ahead and light up a cigar. So this week I've got the Alec Bradley Prensado. Prensado. Put the N in the wrong place there. So the Alec Bradley Prensado, and this is, I believe it's a Robusto. It's about 5 inches long and 50 gauge. So this was actually the well, not this one specifically, but the Churchill. So the Churchill's, it's a different size, a little bit bigger. The Churchill Alec Bradley Prensado was the 2011 Cigar of the Year by Cigar Aficionado magazine. So it's pretty good cigar. This has a wrapper from the Trojes, Honduras. The binder is Nicaraguan, and then the filler is also from Trojes, Honduras, and also some Nicaraguan filler as well, as far as the tobacco in there. So the odor smells delicious. It's got sort of a cedar coffee type smell. And we'll go ahead and let's cut this. Just do a straight cut today. So on the pre-draw, or the pre-light draw, it's kind of leathery, a little bit of coffee, and some chocolate. I like that chocolate. All right, go ahead and light it up, and I'll just tell you a little bit more about my notes that I had taken earlier this week. So when you first start it, you get a big taste of black pepper, kind of a peppery explosion, and then that's brief. That settles down pretty quickly, and you get some more of that leathery coffee sort of flavor. Yeah, there's that shot of pepper. Of course, more pepper on the retro hail. That's pretty common. And then as you get into it, it gets a little nutty. Once you get to that second third, there's a little bit of sort of a soury citrus, but it kind of milds out and it becomes more of like a spicy cedar. But you still got a little bit of that pepper. You get to that final third and it's just more leather, coffee. Some of that nuttiness is a little more pronounced and just a little spicy. All together, this is a pretty good cigar. The flavors aren't really overpowering. It's a little bit more on the mild end, but everything kind of blends together really well. It's pretty smooth. I have noticed that it doesn't always burn super consistently all the way through. So I might have to like touch up on it at times as it'll start burning a little unevenly, but otherwise it looks pretty good. It's it feels good, nice and a little spongy and that sort of thing. Okay. Just what? Okay. Sorry, I've got what? No. Yes. Yeah, that is. Okay. Sorry, I've got a house full. I think I mentioned this last week, but yeah, I've got some family members whose house got a lot of damage from the winter storm we had here in Houston a couple weeks ago, and so I've got like 6 extra people in the house. So I think they're leaving now, so maybe I won't be interrupted again. I mean, they'll be back later, but anyway, sorry about that. Yeah, so smoking this pretty good. All right, so we're gonna look at some malware today, and what I'm looking at here's the sample that I'm looking at. Yeah, so this is VirusTotal. This is AgentTesla. I got this from Malware Bazaar. If you want to find a copy, I'll tell you what, I will drop the VirusTotal link here in chat. And if you want to take that and then see if you can find the malware, go for it. I'm not going to share the malware directly. If you don't know how to find it from the data there, then you probably shouldn't be messing with it anyway. Okay, so that's the sample that we're looking at. And yeah, we're going to do some static analysis. So this is pretty heavily obfuscated. So we're just going to kind of get started on it today, looking at the obfuscation, and we're going to try to pick it apart manually. Now normally for something like this, it's a little bit easier to do some dynamic analysis. You can actually just, as it's the code has to execute. And so you've got all these obfuscation techniques that are used to make it hard to like visibly read, but the computer has to be able to read it. And so it will go ahead and decode things, and all the different variables that we're going to try to decode today will be decoded and saved in memory. So if you're doing dynamic analysis, you just got to kind of watch for it, and you can just pick it out of memory. And you don't have to decode it manually. But I thought it'd be a good exercise just to try to go through it manually. I say manually. We'll still throw some Python at it to make it a little bit easier to decode. But we might try to actually do one completely by hand. It might take a while, but anyway, it's not too difficult. So we'll start here in my malware analysis system. So this is a system I have running in AWS. I just launched the AMI this morning. I've got this saved and use it for, malware analysis stuff. Using Flare VM. I talked about Flare VM last week. You can find that. You just Google Flare VM. It's made by FireEye. And it is it's really just a PowerShell script with a bunch of tools put together in one place that you can use for malware analysis. So yeah, you just run the PowerShell script on a new Windows box, and it'll download all the tools. You don't obviously want to do this directly on your hardware unless you just have a machine you can throw away. You typically would do this inside some kind of virtual environment, because what you want to do is you want it to be able to take snapshots and restore those. So as you're running the malware, it might, depending on what you're doing and how you do it, it might actually go ahead and infect your system. And you want to be able to go back to before it was infected every time you do some analysis, so you're starting with a clean system. So I'm using AWS because then I've got my AMI set up, and I can create a new instance, remote into it, do everything that way. Also, I've got all the network locked down, so there's no if it did get infected, it couldn't actually like reach out and contact C2 servers and that kind of thing. There is a time and a place for that, where you want to see the C2 and see what the C2 servers are doing, but you definitely want to be in control of that. So you want to control your network. Don't let it do anything unless you specifically want it to. And if you choose to do any of this activity, you're assuming any risks that might come from this. So my little disclaimer there. Okay, so let's see. Let's have a look here. Where did I put that sample? It is. Nope, that's the zip file. Oh, here it is. All right, so here's the sample. And you can see it's just the name is the hash. So if you look at the VirusTotal link and you look at the SHA-256, that's the name here. We'll start up. We'll take a look at PE Studio just to kind of see a little bit of info about this file. All right, so PE Studio just gives us a bunch of information. It reads through the file, reads through the headers, and kind of summarizes it for us. And we can see here that this is actually .NET. So we've got some C# code. Now, that makes it easier because there's you can actually decompile .NET stuff and get pretty much your original source code. So we don't have to run it through Ghidra or anything and try to do analysis that way. We can just use some tools built specifically for .NET, get the original source code, and then work from there. So now that we know it's .NET, let's try ILSpy. Oh, and actually I already loaded this in here. Yeah, so this is, I've loaded the malware here in ILSpy. And the first thing I notice is look at all these different modules or classes that are loaded. Notice they're using, I believe it's Mandarin or Chinese characters. Not entirely certain, but I think so. I think I remember looking it up, and that's what it was. So, yeah, this is using wingdings. Is that what that is? I don't know. So yeah, that's kind of the first thing we've got to get through is dealing with that. Now it's not too difficult. When I first loaded it, it brought me to the main function, which is actually this one here, and we've got two classes inside of this. And so these are the ones that we're going to actually be working with. So we're just going to look at these two classes today. Notice again once you get into the class and you get into the different functions and things inside of it, that the names, at least they're using the English or the Latin alphabet, but they're still pretty random, and it's makes it a little bit more difficult when you're doing static analysis with function names and classes that you can't just read or remember what they are. But we can get through that. So let's see, we've got a bunch of them here now. As we look through this further, we can notice in both of these they're using kind of the same obfuscation techniques here. So we're not going to go through all the code today. Mainly I'm going to kind of pick out some of the stuff, these strings that are being generated, and we'll put together some Python that'll help us decode all of these. Oh, you know what? I don't like the way this looks. Now we can work with it, probably. I was actually looking at this in .peak last night. It was slightly different, but I think it should still work. Okay, so we'll just start here with this function. We're creating a string. We're calling it array. It's just a new string. We've got this another array of integers. It's 36 bytes in length. And then what we're doing is we're going through this array of integers and assigning values to each byte in that array. But notice, so we've got this array2. We're referencing the 35th object, which would be the last byte in the array, because you start counting from 0. Yeah, so it's already starting to get a little uneven here, you can see. And then we're assigning the value 54 to it. But then the next line, we reference the exact same byte, 35, and we're assigning the number 97. And then we're going through and we're assigning the number 56. So again, this is just obfuscation. Like there's nothing really functional about all this, at least these first two lines. So when you're assigning a variable in C# and in most languages, you're going top down, and you can reassign a variable to a new value, and that's what we're doing. So we've got the 35th or the 36th byte of array 2, or index 35, I guess would be more accurate, of this array 2 is getting assigned to 54, then it's getting assigned to 97, then it's getting assigned to 56. So these two it's just junk code. It's just extra steps taking to make it harder to analyze. So, but we can tell that this byte ends up being 56, and then this becomes 101, and then this is 49. And so on. All right, so we're assigning all these numbers, building this array out, and then when we get to the end, we're making this new new string, and we're calling the char function. So we've got all these decimal values. We're calling the char function, basically going through each byte in that array and converting it to a letter, to ASCII, or a letter or a number. Sorry, I think this one. Well, we'll just decode it and see. Now, if we wanted to do this manually, like 100% manual, which, you know, I don't really recommend that you build your actual day-to-day processes by doing everything manually. That's one of the things about you know, this kind of work. You want to automate as much as you can. But let's just take a look at doing this manually, just so we can see how this works. There's only 36 bytes, so that shouldn't be too hard. All right, give me a second. Didn't have this prepared here. Let's switch to CyberChef. There we go. Okay, so we'll take a look at this in CyberChef. Okay, I only have one window up, but that's fine. I'll just trust me when I say I'm copying stuff directly from the malware we were looking at. Okay, so the first one, so with 35th position, or index 35 on that array. So we assign it to 54, 97, and then 56. So we'll just put in 56 here. We'll do this from hex. Then the next one, the final assignment is a 101. Sorry, not hex. My bad. It's from decimal. There we go. All right, 80. Okay, this is what I was thinking it would be. Yeah. Okay, so we've got 101, then we've got 49. Hold on. Yeah, 49, and then 52. Then position 31 is 56. 30 is 101. 29 is 52. 28 is 57. I gotta scroll down a little bit. Oh, missing a space there. Where was I? 28. 27 is 50. 26 is 97. All right. This is boring. I don't need to keep doing it manually. So I mean that's one option. If you really just wanna pick it apart and do it manually, you certainly can, but it is going to take up a lot of your time, and there's definitely better and easier ways to do this. So let's just switch back to our box here. Okay, now let's see if we can throw some Python at this. Now I've to be perfectly honest, I've looked at this malware, but I haven't really picked it apart like this. So we're kind of doing this live. So if I screw some things up, I thought we'd add a little excitement and just kind of see what happens. All right, so let's start by just like copying all of this nonsense. And what I want to do is build a decoder where I can take these and eventually I think we may, maybe next week, or we'll see, maybe we can actually just extract this stuff without having to copy it over. But I want to basically assign this to a string, pull out all the information, or all the actual relevant useful information, and then see if we can decode it and have it do that automatically. We want to write some functions that we can use repeatedly, so that for the next bit, so that it does this a lot throughout the code, this method of obfuscating. Later on it does some other additional things, like it adds some extra characters that then have to be stripped out. It reverses them, some stuff like that. But this basic technique of just creating an array, assigning each position to multiple integers repeatedly, and then converting those to using the char function to decode it, that happens all throughout this thing. So Since we know that that happens repeatedly, we can just go ahead and write some code to deal with it. All right, so just I open a new project here in PyCharm. Now I will admit my standard operating procedure for Python is usually just Vim. But yeah, I've been trying out PyCharm. I like it. I mean, you can definitely do some more stuff with it. But all right, so let's just make a function here called decode array. All right. And let's see, what is this function here? All right, I want to be able to keep track of where I am in this original source code. So I'm going to go ahead and use the same function names that they are in my code to kind of deal with some of this. So let's call this decode that. Bunch of nonsense. All right, so decode array is going to need to take in an array. So we'll call this. And the other thing, if we go back and look at our source code, so we can see here we've got three. It's assigning the variable it's assigning the variable 3 times, and it follows that pattern. But when we look at some of these other functions, let's see, where it was, yeah, okay, this one's doing it, 4 times. So we need to be able to account for some of these changes where it's not doing the exact same thing every time, but it's pretty much the same thing. It's just not following the exact same pattern. So since the number of times it assigns things, it seems to be consistent for each individual string that we are obfuscating, and then we need to de-obfuscate. So we can just make that a variable that we also pass. We'll call it, or I don't know, index of string, something like that. Okay, now we've got our, what did I call it? Let's take that whole array. I think it's still on my clipboard. I guess we'll find out. And we'll make that into a single string here that we can work with. Since it's multi-line, we'll use the 3 single quotes in Python. Let's paste it. Nope. Okay. It's not still in my clipboard. Okay, let's go back to this one. This is one we're going to start with. Copy all this. All right, go back to Python. Let's paste it in there. Okay, so we've got all that as a string that we can do stuff with. And the only thing we really need to pick out is this decimal number at the end. So we can go through that whole thing and assign those. Actually, let me change something here. Okay, so I'm gonna use regex for this. So let's import RE. That's the Python regex implementation. I'm just gonna call this to decode. There we go. All right, but the reason I did that is the array needs to actually be a list. So all right. We've got our string. What we're going to do is we're going to pull out every one of these decimal numbers here at the end using regex, and then add that to our list so that we have a list of integers. And then once we have that, we're going to pass it to this decode array, which we still need to build. Okay, so let's do, what do we want to do? So, yeah. Okay, we need to, all right, we need to extract the data. So first thing, let's start with our regex. And this is pretty simple. It's at the end of the line. It's just a decimal number followed by a semicolon. So we'll put it inside parentheses. And in Python, when you're using a find all like this, what it's going to return is what's inside parentheses. And if you have multiple parentheses, then you end up creating a list of each thing inside each parentheses. So what we need a number, so we'll use /d plus because that's one or more. If you don't know regex, maybe we can talk about that sometime. But this is what we're doing. All right, then we need the semicolon. And then we need to pass our, what did I call it? Yeah, string to decode. There we go. We'll assign this to a variable. And then let's just test our code here and print it out. Now let's see what happens. Okay. Oh, it's because I have this empty function here. That's what it is. Yeah. Okay. I forgot about some of the initial setup stuff that PyCharm does. So it created a couple of functions and was assigning things, and it basically just like prints out hi. And I still had some of that code in there. So I've taken that out now. This should work. Switching between too many windows here. Okay, here we go. All right, so that works. So we've got this array now of all of the integers. That's what we're looking for. So now that we have those, we can start doing some other things with them. Now, the one problem that we will have here is that because we're using find all, and eventually we think about what we're going to do with this. So we're going to be converting each character or each integer in this list, in this Python list, using the char function, converting it to its ASCII equivalent. But using find all, we're actually returning a string. So we need to make sure that what we're actually getting from this is a list of integers instead of a list of strings. So that's the next step that we need to do, is we need to go ahead and convert these. And we can actually in Python just kind of do this all on the same line. So let's go back to our code. Where did my mouse go? All right. You guys ever worked somewhere where they do what they call pair coding? I've never done it, but I imagine it sucks. Basically, you partner with somebody and one person writes code and the other person watches. I don't want people watching me write code, but here I am doing it live on the internet, so yeah. Okay, so we want an integer And then we can do 4s, and there we go. That should work. Should basically get the same thing returned, except now these are integers instead of strings. If you notice before, each of these numbers had a single quotation mark around it. That's because it was a string. Now there isn't one, so we're dealing with integers. Okay, now that we have that, let's see. We'll have our results. We will call decode array. We'll pass our array of strings, and then let's see. The second argument was the index that we're doing. All right, so we've got that. Now let's start pulling this apart. So because we know that it's every third character in the array, so the array, everything was loaded in the same order that it was found in that initial, long string of all that obfuscated stuff. So since we know it's every third character, so what we can do is we can use the mod function. So if you remember, high school math, mod essentially is just returns the remainder. So like 4 mod 2 is 0 because there's nothing, when you divide 4 divided by 2 is 2 with remainder of 0. If you remember that from math. But if we did 4 mod 3, the answer would be, 4 divided by 3, it's 1, remainder 1. And so you actually get 1 as the result. And so what you can do is you can use the mod function when you're going through things like this to match when the result is 0. So we're basically just doing stuff on the third item. Okay, so we're gonna, let's see. All right, gonna create a new list here for our results. I don't need that breakpoint there. Okay. And then we're gonna go through a loop. So let's see, we've got the we've got an array. Each array has an index, so let's get the index and then the item in it, and then we're going to enumerate our array, which we call, there we go, array of strings. All right, so we're going to do a for loop. We've got 2 variables that are assigned in each loop through here. So the index, which is going to be the number that we are in the array. So like, the 0th item, if I were to reference array of strings 0, that would print out the very first number. And here we'll do that as an example real quick. So if I just say print array of strings, and then we're going to reference the first item. Again, we start counting from 0. There we go. So we just got 54. 54 was the first item in that array that was assigned. Okay, so what we end up returning here, the index is going to be this 0, and then the item is going to be the actual value, which is 54. Okay, so we're looping through this, and then we just need to add an if statement, and let's say, but since it's since we're counting from 0, we need to allot for that. So what I want to do is just return like the third item in the list, because it does it 3 times, and the third one's the only thing that actually gets stored. But since our index starts counting from 0, it actually would be 2, but 2 mod 3 isn't going to be 0, so it's not going to match. So what I need to do is take my index and add 1 to it. let's actually let's put parentheses around that as well. And then in Python you just use the %sign or mod. I think C does as well, and some other languages. So we're just saying the whatever the current index is, that mod, and then we will use the index of string. So this is the second value that we pass to our array or our function, and it's going to change depending on which thing we're trying to decode, and it's which item in the list we want to. So every third item essentially is when this is going to return true. And then what I'm going to do is I'm building a new array which we already called results. We're just going to append to it, and then if this other statement is true, what we want is whatever the current index is in our loop, we want that value to be added, appended to our list. Okay, now we've got that. Now we've just trimmed down our array. So all right, let's print it. So let's just print results so you can see what this is done. So again, we've got an array of integers here, but it's not the same. It should be a smaller set, and it should just be every third character. So we'll double check that. So we've got 56, 101, 49. We'll go back and look at our source code here. So we want the third item. So notice we didn't get these two. We got 56, then we got 101, and then we got 49. Okay, so we got that. And if we wanted to, you could go from here and take this to CyberChef, but we're already in Python, so let's let Python do the work. All right, so I'm calling this as a function. We need a return value, so we'll just make something called return value. And then what we'll do is we'll just use join. We'll call the char function. So this takes a decimal value and converts it to ASCII. And we'll do for I in results. Yeah. And then we'll just print this real quick. And there we go. So that's what we're getting from that first bit of data. So some kind of ID or something. I'll have to figure out what that is later. Okay, so now we've kind of got the basics of this working. We can start going through and taking other all these other places where it's got this obfuscated code and to start decoding all of it. Okay, but actually what I want to do here, I don't want to print it. I want to, return. And then this is giving us some results. Sorry, the value that gets returned here is assigned to results here. So we can, for now, let's just print. So we'll just add a print results function here. And let's make sure I didn't typo anything. Okay, so that works. Now all we need to do for these other functions or for these other strings is basically just create some new functions here that do the exact same thing, assign all of it to a variable, pull out the numbers as a array or a list of integers, pass it to decode array, and then print. Okay, so that was the first one. And actually, now that I've done that, let me change some names here to make this easier to track. So we've got, okay, so this function actually has several things to decode. So we'll call this, I think it was called array2 in the code. Yeah. Okay, so we'll trying to use a lot of the same names in my code here, so that when we go back and try to do some more analysis, we can actually call these things using the same function names that are in the source code, and it can even just maybe copy and paste some of the code directly and just Pythonize it, if that's a word. So moving on to the second bit. So once again, we're going to copy. Let's see, we'll start up here. Copy all this. And this is array 3. So we'll make a new function here. Decode. All right, let me just copy this. I need more clipboards. Okay, we'll call this one array 3. All right, and we're just going to do all the same thing. So string to decode equals, let's go back. I lost it in my clipboards. All right, so we will paste that in. And, you know, now that I think about it, looking at my code here. Okay, scrolling wasn't working. All this stuff here at the end is being repeated. I wonder if I should just put it all in the... I hate using Windows inside Mac. Yeah, it would actually make sense to put this in the decode function instead of doing it here, because this is going to be the same for all of them. So let's do that instead. And then we'll call this what was it? String to decode. Yeah. Yeah, that should work. And then for this, let's see. Okay, so trying to not have to repeat a lot of things in each function that we're defining, and putting it all in one that's going to do all the work for us. Okay, let's see if my changes work. Always test your code. Nope. Oh, that's right. I changed the function name. So let me fix that. So this was array 2. I think that's the one I just modified. Yeah, okay, so that still works. Great. And then we want to call... nope. Same thing for array 3, but I still need to finish that function out. Which really all I need to do is add this to the end. Now I want to go ahead and keep this bit separate from the decode array, because later on it does some other things to it. Like I said, it reverses it, or it maybe adds some extra characters that have to be stripped. So I want to be able to do that in the individual decode function for each array that we're decoding. So let's go back up to decode 3. So I'd assigned the value here, and I believe this one's the same thing. It's just 3. Yeah. So it's assigned 3 times, so we can use the same 3 here. Run that, and there we go. So now we've got 2 strings decoded. Okay, so that wasn't so hard. Oh, that's okay. That's why I was using .peek. Yeah, I had this trouble with dnspy as well. dnspy couldn't run, or it couldn't decode all this. I think it's all this extra like Unicode crap, not ASCII and all the function names that I had trouble with. So let's kind of switch gears here. Let's pull this up in .peek instead. So in case you missed that, I had an error there in ILSpy. It was having trouble decoding things, and it didn't find the rest of the class that we were looking at. So I tried this in a few different tools, and like I said, dnspy just pretty much I'd look at a class and it was just like it said some kind of error about how it crashed and it couldn't decode it. ilspy just gave me an error about it couldn't find the rest of the code. But I'm pretty sure when I looked at this in .peek, it had all the datas. So we'll give .peek a minute to load, and then we can maybe get the rest of these strings and pull them out. So we've got some, some kind of UUID here that's being used, and then some of the other strings that we're going to pull out actually going to be like, yes, I accept. Okay. We're actually going to see it like building out commands. So instead of just calling a command, it's going to, use this same technique to like build out a string that it then uses as a command later to call it. And then we'll also see some URLs that are used for the C2 or the second stage. So this is just basically a first stage loader. It's going to execute. It will access a server online, download some additional stuff, and then from there, it's got to decode that payload, and then that's going to execute and move on to the stage 2 of whatever it's doing. I'm pretty sure that the stage 2 server is actually offline now, but I did get a copy of that payload before it went offline, so I've got that. I don't think we're going to get to it today, but because it's already 15 minutes in. But yeah, when we do get to that, I've got that code and we can start picking that apart. All right, now, if I remember correctly, this is actually our main function here. Yeah, and these are the two that we were looking at. Okay, this is the one we were decoding here. This ZBZD blah blah blah. Yeah, here we go. So it looks slightly different, but not terribly. It's still doing the exact same thing. We're pulling out that one we've already done, and actually this calls it num_array1. Wait, is this the right? No, actually, I think I'm looking in the wrong place. Let's see, which one did I do already? It was FNUT blah blah blah. Okay, was that here? Oh, you know what? It looks like it's actually... Oh, no, wait, there it is. Okay. Yeah, this is the right one. Okay, so it calls this one num_array1. For consistency's sake, I'm gonna go ahead and change this to use the exact same. Since we're looking in .peek now, we'll use the .peek name. And then we'll go back up here and change this to, I think it's going to be num_array2. Yeah, num_array2. Then we'll jump to our main function and fix that here as well. This bit doesn't matter so much, but I think it'll be easier when we get this all done if we're using, the same names that we're seeing here. Okay, make sure I didn't typo anything. Nope. All right, it's working. So we've got num_array1 and num_array2 from this FNU whatever function that's done. So now we're enumerating this, just assigning these. So it's basically building out it would be a C# list, I suppose you could call it. It's an enumeration, but yeah, it's just adding these two values to this. We'll come back to that. Right now I just want to kind of get through these arrays and get them decoded. Okay, so now we've got a new function here doing the same stuff, but let's go ahead and make a new Python function for decoding this. So we'll keep with our same kind of format. So we'll call it decode, the function name, and I think this was num_array1. Yep. All right. And we'll copy all this. Now notice this is a shorter one. So this is actually only a 19-byte array. And but we need every 5th character in this one. So let's copy that. By the way, if any of you are like professional engineers who write in Python, I apologize. I'm not an engineer. I do other stuff, and I just use Python as a tool. So there's probably better ways to do some of this. At any rate, okay, so we've got that, and I'm just gonna cheat here and go back and copy this code. Should have brought my mouse from inside using the Mac touchpad. Here is getting annoying. It's just not scrolling well in Windows. All right. Oh, it's working now. Okay, so that when you change this to a 5, that should work. Now let's just call this in our main function. So we want decode, and it is this HOJ blah blah blah. Okay, so this is where we're starting to get some weird stuff. That doesn't make any kind of sense. So let's go back and look at our code. After this is assigned, so this is all right, num_array1. We're creating a string, and we can see here we're replacing X with nothing. So this is where it's added some nonsense in there that isn't needed, and then it's decoding it. This is, yeah, it's just obfuscation, you know. I mean, it doesn't make sense programmatically or, you know, functionally to do this, except it's just making it harder to decode. But not that hard, because all we got to do, let's go back to the function where this was at. So this should return a string, I believe. So we can just do a replace X with nothing. So the same thing. Now if we take that, okay, so we get something there. And let's see, does it do that here? Okay, well, if we look at this a bit more and kind of decode more what it's doing, again, we've got all these weird function names and stuff, but one of these is going to reverse this. So just to reverse a string in Python, we can add that to the end. And we can see what that decodes to is get type. So again, what it's doing here is it's building a string, which is then it's going to use that string as part of a command for other things it's going to do later. Now the next one, we've got 25 bytes, and it's also every 5th character that we want. And let's make this function so, you know, I'm copying things in the wrong order. Hold on. Okay, so we'll use this. So this is the same function, but this is going to be array 2. Yeah, so we'll call this one decode HOJ blah 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 2. And then let's see, string to decode equals. And then we'll just, again, copy. I should be putting this in like a scratch pad or something. Okay, we got that. decode it, print it, call it from main. And yep, so the next one is assembly. So we've got get type, we've got assembly. Here's another 19 byte integer. This is num3. Hold on. Let's define the function first. Nope. We'll call this num array 3, and yeah, just kind of keep doing this. Was it strings code? All right. I think we're almost done with this section here. Then we'll decode and print. I know how exciting it is watching somebody write Python and doing the same thing over and over again. Exciting action television here. Okay, what went wrong? Oh, I think I'm using the string to decode, right? What did I call it? Strings to decode. There we go. Okay, so get type assembly load. All right, it keeps doing that. I think this is kind of the same. Is this the same thing? Yeah, with the X. All right, well, we can come back to that. Like I said, it's pretty repetitive. But let's now switch to this function and look at what this is doing. So this is going to be slightly different, and I think in somewhere in this class is where we're going to actually find the URL for the C2 stuff, or the second stage, that is. All right, string to decode equals. It's not this one. This is too short. I don't remember what this is. It's probably more the same kind of thing. Oh no, wait, there. This is used later for decoding stuff. All right, so this is num array 1, and this is 10 bytes, and we're doing every fourth character. Okay. You know, I'm going to copy this to my little scratch pad over here off screen. So I don't have to keep scrolling around. Okay, got that. Where was I? Let's find the end of that function. There it is. Paste that in. I don't think this one does all the replace and stuff. Let's just print it out and see what it does. So this is every third character. Oh, and we need to call it in main. Which one was this? I think it's the G blah blah blah. Yeah. Okay, so we're getting something here. Don't know what that is yet. We'll have to figure it out. And it doesn't seem to be doing anything else with it here, at least. Just calling it string 1 and then, yeah, converting it. Let's get this next one. This one's a bit longer. This is 69 bytes. And it's every fifth character. Hold on, before I do that, let's array 2. going to decode equals, and then let's go ahead and get that. Oops. Wrong button there. And this is every fifth one. Now let's put this in here and, okay, I didn't save it. I think we're getting into the stage 2 stuff here. We can start getting some URLs. All right. Grabbed all that. Let's call this function. Let's see what it does. Run it. Oh, there we go. And yeah, it is reversed. There we go. Do that to reverse it. Okay, and then we've got a URL. Now it does a bit more of that. I'm going to finish kind of coding all the rest of this offline, because you basically seen me do the exact same thing and just copy and paste the code over and over again. I did want to show you some of the different types of things that it decodes, so we can see that and how it does kind of change how some of it ends up eventually. It uses different indexes. Sometimes it reverses. Sometimes it's got stuff that has to be replaced. I don't think there's anything else as far as like the decoding of these strings that it does, as far as other techniques for obfuscating them. Yeah, so there's multiple URLs here that get decoded. I've got one of them. Okay, it does some more replacing X. And then some of this stuff, this actually gets used when it starts parsing the second stage. So like I think this ends up being a less than p greater than. So when you actually look at the second stage that gets downloaded, it's in HTML, and so what it does is it's defining some HTML strings. So you've got less than p greater than, which is a paragraph in HTML, and then this one I think is the closing of that, so less than /p greater than, and then it's going to use those. See, it's defining them as strings, and it's taking like the values and it's replacing them. Anyway, we'll get into that next week. I'll finish defining all this other stuff offline, and once we get that done, then next week we can come back and look at this. We'll have all of these strings defined, and then we can start looking at what the code is doing with them, which essentially what it's going to do is it's going to download or try to download a second stage payload from some of these URLs. Then it's also obfuscated, and you've got to decode that. Actually, I've got a sample of that. Let me show you that. I can find it. I'm trying to remember where I put it. Probably put it in my malware directory. Give me a second. Just want to show you real quick what this second stage looks like. Talking too much and my cigar went out. Okay. Okay, let me switch windows here, and it should be that one. Yeah. Okay, so this is what the second stage payload looks like. So you can see there's a lot of repetition in there. We're gonna have to strip some of that as we go through the code. We'll see how it does that. We'll strip some of that out, and there's probably some other processing that has to happen, and then we'll end up eventually with some code that gets executed for whatever the second stage of this particular malware is. So, again, doing it manually like this can be kind of tedious. It is worth at least understanding how that happens and kind of looking through this, so you can understand what the malware is doing, perhaps at a more in-depth level. But really, if I was doing this, I'd use some dynamic analysis techniques. So I want to get finished with doing all the static stuff, so we can kind of look at that and understand it, and then we can go back and do some dynamic analysis in a few weeks. This might take a few weeks to get through, since we're going to be writing code live. But then we can do some dynamic analysis, and we can probably get that through in like one episode instead of like 3 or 4 episodes, because it's just a lot quicker to just pull these values out of memory. So hope that was at least informative, and we'll pick this up next week. Just a quick, no, we still have some plan. We'll have another CTF coming up sometime. I've got a date, but we still have some planning to do. I don't think I want to announce it just yet. This is actually through my my employer, ConnectWise. So I lead the threat research team at Perch Security, but Perch was acquired by ConnectWise last year at the end of the year. So now with Perch, a ConnectWise company. And anyway, ConnectWise is really excited about hosting CTFs, and we want to do 1 a quarter is the current plan. So we've got one coming up here in a month and a half, 2 months, less than 2 months. It's going to be focused on MSPs because it's ConnectWise and that's their target market. So that's coming up. I'll give you some more details as we get closer. And I think that will do it for this week. Don't forget, if you're running a hosted Exchange server, patch your shit. If you've been hiding in a hole somewhere, you maybe haven't heard this, but yeah, there was a major, actually a few large vulnerabilities for Exchange released this week. A SSRF plus a RCE that kind of combined together allows an unauthenticated user to upload and run files on your Exchange server. A lot of bad guys have been doing stuff with it. We've seen them dropping web shells. China Chopper is one that a lot of people have seen. Early yesterday, we started seeing people dropping some malicious PowerShell as well. That we've been decoding. It looks like it kind of matches the signature for Veil framework, so they're using that to like obfuscate the code, and then we've seen it doing some like Mimikatz, which lets you steal credentials, and Cobalt Strike for C2 activity. So yeah, a lot of bad stuff. Saw a report yesterday that over 30,000 US companies are affected. So definitely, if you have a hosted Exchange server, make sure your stuff's patched. Look for those web shells, because if you weren't already patched, you probably have something now. There's been a lot of automation going on by a number of different adversaries. Halfium's been the big one, but we start seeing this new PowerShell stuff, which looks like it might be coming from somebody else. So yeah, take care of that. Patch your shit and clean your web shells up. And I think that'll do it for next week. That'll do it for this week. Next week, we'll come back. We'll keep looking at this malware, looking at analyzing it. And until then, if you're in a CTF or anything else you're doing, if you get stuck, don't forget to try harder, don't panic, and always, always RTFM. See you next time.
It's It's a madman, the battle's far.